everyone, Bella here, bringing you some mission rocket science from the Estes Education Studio. Today, I'm going to share one of the labs we do in our free Missing Mass unit plan. This is Law of Conservation of Mass Lab. In the Missing Mass unit plan, students will answer the question, how can they create a model of chemical reactions and the law of conservation of mass? Students classify chemical and physical changes, identify indicators that a chemical reaction has taken place, and do some experiments that show in the law of conservation of mass, a chemical reaction has taken place. Students identify physical and chemical reactions, identify indicators that a chemical reaction has taken place, and perform some experiments to see the law of conservation of mass in action. I'm going to show you one of those experiments here in our studio today. Chemical and physical changes are happening all around us. Cooking, eating and digesting food, driving a car, all the time. Physical changes, like getting a haircut, are changes in appearance or form. Your hair doesn't become a different substance when it's cut. However, in a chemical change, the matter changes. The molecular structure is different because the atoms' bonds break and are rearranged. A chemical change, like frying an egg, is usually referred to as a chemical reaction. A long time ago, scientists thought that sometimes in a chemical reaction, substances just disappeared. Today we know that due to the law of conservation of mass, in a closed system where nothing is allowed in or out, matter is neither created nor destroyed. Now let's do an experiment. Feel free to grab your own supplies and do the experiment right alongside me. I have here vinegar and baking soda. You're going to use your graduated cylinder to measure 15 milliliters of vinegar into your Erlenmeyer flask. Next, you're going to have a small cup on your scale and you're going to zero it out. And then measure 5 grams of baking soda into your cup. Perfect. Next, you're going to take your funnel and your balloon and stretch out your balloon a few times. And then put your balloon at the bottom of your funnel and then add your baking soda. Next, you want to make sure all the baking soda is at the bottom of your balloon. You're going to take the neck of your balloon and put it over the mouth of your flask. But be really careful not to let any of the baking soda fall into the flask. Measure the entire mass of the system you've just created. We have 65.3 grams. Next, tip the balloon upside down and let all of your baking soda fall into the flask. And give it a little swirl. When it looks like your reaction is complete and it's stopped bubbling, record the mass of your products. We have 65 grams. Next, carefully remove the balloon. Tie it, again, very carefully, trying to not let any of the gas escape. I twisted it a little bit to help me out. All right, next, measure the mass of your balloon and the gas. We have 3 grams. Then measure the mass of the vinegar and baking soda. This shows 62 grams. So our total mass of our system is 65 grams. There you have it, the law of conservation of mass in action. Now I walked you through the steps of this experiment, but when your students do this, we want them to design the experiment themselves. You tell them the materials they're allowed to use, then they need to come up with a detailed procedure that shows the law of conservation of mass in action, which then you approve before they perform the experiment. I hope you had fun learning about our missing mass unit plan today. Check the description for a link to the full unit plan and all our other free resources. Join us next time when we examine the law of conservation of mass with a rocket launch. If you like this video, don't forget to like, subscribe, and hit the bell to be alerted for new content. Happy launching!